A very good evening to all of you. Welcome back to my channel. This is Shivam Shukla and here I am to solve a problem on engineering mechanics. It's a problem on dynamics. It's a problem on module number 6, that is kinetics of particles. The topic is work energy principle. It's a type 3 problem. Problem on combination of work done by weight force, friction force and spring force. So work done by weight force, then work done by friction force and work done by spring force. Let's see how the question statement goes as. A spring is used to stop a 100 kg package which is moving down a 30-degree incline. The spring has a constant K is equal to 30 kilonewton per meter and is held by cable so that it is initially compressed by 90 mm. See, we have been given the initial deformation, that is at position 1. Already the spring is initially compressed by 90 mm, that is x1 is equal to 90. If the velocity of package is 5 meter per second, at position 1 already the velocity is 5 meter per second. So when it is 9 meter from the spring, determine the maximum additional deformation of spring in bringing the package to rest. Assume coefficient of friction as 0.2. Let us write down the given data as well as what are we supposed to find. So now I'm writing it over here. Given data one by one. M is equal to 100 kgs. Then K is equal to 30 into 10 raised to 3 Newton per meter. Initial compression of the spring, that is x1 is equal to 90 mm, that is equal to 0.09 meter, that is we have multiplied it by 90 to 10 raised to minus 3. If the velocity is v1 at position 1 is 5 meter per second, when the distance is given, we are supposed to find the additional deformation. Even mu k is given to us as 0.2. Now what are we supposed to find? Friends, we are supposed to find the maximum additional deformation, that is x. We have considered, I can write it maximum deformation as x. Okay, so I can write it over here, maximum additional deformation is equal to, let it be equal to x, that we are supposed to find. Okay, then let us go step by step for getting the values. Let us first try to draw the diagram. Let's draw it very clearly. The diagram should be there in front of us. Step 1 is to draw FBD. So step 1, draw FBD. Draw FBD, and here we will be going ahead with the free body diagram of this. Okay, now even on this I can draw it like this. Even this will be drawn as a stopper over here. The angle is of inclination plane is 30 degrees given to us. If I see for this, even the stopper is there with us, and even the spring, if I see, it's there already being compressed. Now I'll be drawing the blocks at position number 1 and position number 2. This is the block at position 1 and this is the block at position 2. I can show the two positions of the block. Here is position 1 and here is position 2. The distance from position 1 to position 2 is nothing but 9 plus x, because already it is being deformed by x. So 9 plus x meters. Friends, now I can show the forces. This is the normal reaction N. This is the frictional force 0.2 N. This is the weight which is acting vertically downward, which is nothing but 981 Newton. 100 into 9.81 Newton, so 981 Newton. I can resolve it accordingly. This is the y component of it, tilted y, and this is the tilted x component of this. So I can write it. This will be 981 sine of 60. Why? Because this angle is going to be 60, and this will be 981 cos of 60. So this is the way how the entire free body diagram is going to get completed. Now we will be going ahead with step number 2. I can write it. Step 1 is done. So step 2 will be kinetic energy. Kinetic energy at position 1, that is T1, is equal to half into m into V1 square is equal to half into 100 into 5 square. Therefore, T1 is equal to 0.5 into 100 into 5 square. Value is 1250 joule. So therefore T1 is equal to 1250 joule. Now let's go ahead with the second value, that is kinetic energy at position number 2 is equal to T2 is equal to 0, since the block is at rest, comes to rest. The block comes to rest at 2. So this is done. Now let's go ahead for step 3, that is work done by different forces. So I can write over here step 3, work done. So I can write down one by one. First will be work done by weight force. It will be is equal to U1 is equal to plus mgh. Therefore U1 is equal to 100 into 9.81 into h. Friends, if you want to see the value of h, let's go back to the diagram again, and over here it is. I'll be just drawing this. I just want to complete this diagram. Let me show it very specifically. Even this angle is 30 degree, as is the corresponding angle. Now what is h? If you see, friends, this entire opposite side is h. So in this triangle, sine of 30 is opposite, that is h, divided by hypotenuse, that is 9 plus x. So h will be 9 plus x into sine 30. So I can write it 9 plus x into sine 30. Therefore u1 is equal to 981, that is 100 into 9.81 into sine 30. Bracket completes. So it will be 490.5 into 9 is equal to 4414 plus 490.5 in terms of x, the whole in terms of joule. This is work done by weight force. Now work done by friction force. Second, work done by friction force. So here it is, u2 is equal to minus mu k, mu to the base k into n into s. Therefore u2 is equal to minus 0.2 into n. Friends, if I apply the condition of equilibrium on this particular block which is at position 1, I'll be getting the value of n is equal to 981 sine 60. I can write it over here, friends. It will be, n will be 9 plus 981 into sine of 60 into S. S is nothing but 9 plus X. Since I can write it, since summation Fy is equal to 0, so therefore n minus 981 sine 60 is equal to 0. And therefore I can write it very specifically. Therefore n is equal to 981 sine of 60. This is done. Friends, let us go ahead. Let us just simplify this equation. U2 is equal to, it will be minus zero point 0.2 into 981 sine 60, 981 sine 60 into 9 plus x. So I can write it minus of 169.914, 169.914x, and here it will be into 9, into 9, I'll be multiplying, minus 1529.227 minus 1529.227, the whole in terms of joule. So this is U2. If I write now U3, so work done by spring force is gonna be third work done by spring force it will be U3 is equal to half K x1 square minus x2 square. Friends, x1 is already there with us, that is 0.09 meters. What about x2? If you can just read the question once again, it is clear cut given that if the velocity of the package is this much when it is 9 meter from the spring, determine the maximum additional deformation of the spring in bringing the package to rest. That means it will be further compressed. So since it will be further compressed, that is why the value of x2 is going to be x plus 0.09. That will be your x2. So let us write it. So it will be 0.09 plus x in terms of meters. Therefore, now I'll be writing it further. Therefore, U3 is equal to half into K into x1 square, that is 0.09 square, minus of 0.09 plus x the whole square bracket. Therefore, U3 going ahead will be 2 ones are 2 15s are. So 15 into 10 raised to 3 into 0.09 square minus of in bracket 0.09 square plus 2 into 0.09 into x and plus x square. Okay, let us go ahead further. So therefore U3, finally U3 is equal to 15 into 10 raised to 3 into 0.09 square minus 0.09 square minus 2 into 0.09 into x minus x square. Okay, so this two things are going to get cancelled. Therefore U3 is equal to, let me multiply it directly. 15 into 10 raised to 3 into 2 into 0.09, value is 2700. So it will be minus 2700x minus of 15,000 x square. The whole in terms of joule it's gonna be. And we are supposed to find out the value of x. Now let us go for step number 4. Very clear and easy step. Step 4. By WEP, by work energy principle, summation of U1 to 2 is equal to T2 minus T1. Therefore, algebraic sum of work done by different forces. One by one we are going to start. 4414.15 plus 490.5x. So it will be 4414.5 plus 490.5 x. Now second, it will be minus 1529.227 minus 1529.227 x. Sorry, this won't come over here. Okay, further, minus of 169.914x, minus of 169 minus of 169.914x. Last, minus 2700x minus 15,000x square, minus 2700x minus 15,000x square is equal to T2 minus T1 is equal to T2 is 0 minus 1250 is your T1. Okay, so let's just do the calculation and get the value of x. First of all, let us take all the coefficients one by one. But before that, minus 15,000 x square is going to be as it is. Let us add sum of the coefficients of x. So it will be 490.5x, 490.5 minus 169.914 minus 2700 is equal to minus 2379.414 minus 2379.414x. If I write about the other value, so it will be now 4414.5 minus 1529.227 again, plus it's gonna be to the other side, so plus 1250 is equal to 4135.273. So plus 4135.273 is equal to it's gonna be is equal to 0. Therefore, just let us do the calculation of this. Very easily it's gonna come. So equation 5, so 3. So now minus 15,000, it's a quadratic equation, is equal to minus 2379.414 is equal to plus 4135.273 is equal to. So friends, the value has come. Therefore, x is equal to 0.4516 meters. So here it is the correct answer. Friends, this problem comes for 6 marks in the examination. Let us see how the marks are going to get distributed one by one. Okay, so I'm just writing it. Here it is for kinetic energy. It will be giving you 1 mark. Again, work done by every force will be individually giving you 1 mark. Work done by weight force, then work done by friction force. Second, 3 marks still here. Work done by spring force again will be giving you, it's a quite tricky part, 1 mark. And last but not the least, if you see the final answer along with the calculation, x is equal to 0.4516 will be giving you 2 marks. So this is the way how the problem gets completed, and it will be giving you 6 marks in the university paper. So friends, please do like, subscribe and share this video. Thank you for watching this video.